You know all those AI models we use every day? Stuff like ChatGPT, Stable Diffusion? They're all built on this incredible piece of tech called attention. For years, the saying in the AI world has been, attention is all you need. But what if it's not? Today, we're going to break down a really exciting paper that introduces a new challenger, an AI architecture called Hyena, and it might just change the entire game. So let's dive into how this new contender works and why it could be such a big deal.
Just imagine for a second. What if you could feed an AI not just a paragraph or a page, but an entire textbook and have it understand the whole thing? Or what if a doctor could give an AI a patient's entire medical history to find patterns nobody else could see? This is basically the holy grail for AI, long context understanding. But there's this one huge problem that's been stopping us from getting there. And that gets us right to the heart of the matter, what I like to call AI's long memory problem. To really get why making an AI read a whole textbook is so incredibly difficult, we first have to understand the engine that's running under the hood of all these current models. And that engine is the attention mechanism. The simplest way to think about it is like this. To understand a single word, like it, in a long sentence, the model literally looks back and compares it to every single other word that came before. It does this to figure out what it is referring to. It's unbelievably effective, but it comes with a massive, and I mean massive, hidden cost. And that cost has a pretty intense name: the quadratic bottleneck. Sounds super technical, I know, but the idea behind it is actually surprisingly simple. And it's the number one reason we haven't reached that long context stream. Until maybe now. Okay, so here's what that actually means for you and me. With attention, if you double the amount of text you give it, you don't just double the work for the computer, you square it. So a 2-page document isn't twice as hard as a 1-page document. Nope, it's 4 times harder. A 10-page document is 100 times harder. You can see how this just blows up, right? It becomes physically impossible when you start talking about a 500-page book. So to build something better, a team of researchers at Stanford did something really smart. Instead of just trying to make a slightly better version of attention, they decided to take it apart, piece by piece, to figure out what really makes it work. They basically set out to crack attention's secret code so they could build something way more efficient that could do the same job. And they found 3 secrets to attention's magic. First, data control. It's not rigid. It actually adapts its strategy based on the text it's reading. Second, its parameters are scalable. This means the model's brain doesn't have to get bigger just because the book you give it gets longer. That saves a ton of resources. And third, unrestricted context. It has the ability to connect the very first word of a book to the very last one, no problem. Any new challenger would have to tick all 3 of these boxes. So with this secret formula in hand, they built something totally new. It doesn't use that brute force comparison method at all. Instead, it's inspired by ideas from a completely different field, signal processing. And they gave it a pretty memorable name: Hyena. And this right here is the fundamental shift in thinking. Where a transformer sees language as just a big collection of separate words to compare with each other, Hyena sees it as one long, continuous signal, kind of like an audio wave. And it turns out you can process a signal way, way more efficiently. The main tool Hyena uses for this is something called a long convolution. Now, don't worry about the math. The best way to picture it is like a super sophisticated echo or blur filter that you just slide across the text signal. So instead of making billions and billions of little comparisons, it just applies one very long, very smart filter to the whole sequence at once. It's an incredibly fast way to soak up all the context. Okay, I know this diagram looks a little complicated, but stick with me because the core idea is really clever. Remember those secrets of attention, capturing the whole context and adapting to the data? Well, Hyena just combines them. It uses that long echo filter, the convolution, to efficiently get the big picture. And then it uses these smart little gates to decide which parts of that echo are actually important for understanding the meaning. It just repeats this process: filter, then gate, building this deep understanding of the text without that insane computational cost of attention. All right, the theory is really elegant, but does it actually work in the real world? It's time to put this new predator in the ring and see how it stacks up against the reigning champion, the Transformer. First things first, quality. Researchers use a metric called perplexity. Just think of it like a golf score for AI. The lower the number, the better, because it means the model is less perplexed by the text it's reading. And look at this. Hyena is right there with a similarly sized GPT model. In fact, it's even a tiny bit better. So the big takeaway here is we're not sacrificing any quality. None. But what about speed? This is where things get really wild. At a pretty long sequence of 8,000 words, Hyena is already twice as fast as Flash Attention. And you have to remember, Flash Attention is already a souped-up, highly optimized version of Attention. So the performance jump here is just huge. But what happens when we really push the limits? At a massive sequence length of 64,000 tokens, a length where standard Attention just completely falls apart, Hyena isn't just a little faster. It's an absolutely staggering 100 times faster than even Flash Attention. I mean, that's the difference between waiting a few minutes and waiting all day. It's a total game changer. And this visual is so cool because it shows us why it works so well. On the left, you see the patterns that Attention learns. On the right, you see the patterns Hyena learns from the exact same text. They're remarkably similar, right? Hyena is discovering the same essential relationships between words, but it's doing it through a completely different and radically more efficient path. So what does this all mean? Where do we go from here? Well, breaking the quadratic bottleneck isn't just some technical engineering feat. It really feels like it's opening the door to a whole new era of AI applications. We might be on the cusp of the dawn of truly long context. This breakthrough completely changes what we can even imagine doing with AI. The researchers themselves put it perfectly. They said, imagine feeding ChatGPT a whole textbook as context, or conditioning on a patient's entire health record. Sounds amazing, and it really does. The possibilities are just incredible. I mean, think about it. We're talking about processing gigantic, gigapixel-scale images as a single whole, not as tiny little patches. Or analyzing a company's entire software code base to find one single bug. Generating a full symphony, not just a 30-second jingle. Or, and this is huge for biology, analyzing entire genomic sequences to unlock new medical breakthroughs. These are the kinds of massive challenges Hyena is built for. So all of this brings us to one big final question. For years, the undisputed law of the land in AI was attention is all you need. But with powerful, incredibly efficient challengers like Hyena now roaming the wild, you really have to wonder, is the reign of the Transformer finally coming to an end? The next few years are going to be very interesting to watch.